Hello and welcome to another GCSE revision video, and in this video we're going to be looking at rearranging and using formulae. Formulae are just algebraic equations and can be treated as such. We tend to call an equation a formula when it has two or more variables. Examples of formula include area equals pi r squared, speed is equal to distance travelled over time taken, energy equals mass times the speed of light squared, or one we've looked at recently, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. What formula essentially do is show the relationship between one variable and other variables. When you have a single variable on the left hand side that is equal to something on the right hand side, then the variable on the left hand side is known as the subject of the formula. In the case of E equals mc squared, E is the subject of this formula. Sometimes on an exam you'll be given a formula and you'll be asked to make another variable the subject of the formula. So let's take something like E equals mc squared and make m the subject of the formula. We rearrange formulae exactly the same way as we would rearrange algebraic equations. The same rules apply. If we're going to do something to one side of an equation, we do it to the other side of an equation. Whatever we do to one side of the equal sign on a formula, we do to the other side of the equal sign on a formula. So for example, if we take E equals mc squared, we can divide both sides by c squared, leaving us with E over c squared is equal to m. And lastly, using the equivalence property of the equals sign, if E over c squared is equal to m, then m is equal to E over c squared. We have now made m the subject of the formula E equals mc squared. Some of you might remember back in June 2012, scientists at CERN reported the discovery of a particle that had a mass of 125 giga-electron volts over c squared. They called it the Higgs boson. Simply rearranging a formula helps us to understand why the mass of elementary particles in particle physics is measured in units of energy per c squared. Okay, well, so much for the theory. Let's have a go at putting that into practice. Let's pick a nice easy one to start off with. Let's take something like the area of a circle is equal to pi r squared. And let's assume that we know the area of the circle, but we want to know the radius. Okay, so all we do is rearrange to get r on the left-hand side. So the first thing we can do is divide both sides by pi. Then the pi's cancel out. So we get area over pi is equal to r squared. Then all we do is take the square root of both sides, bearing in mind that the radius is going to be positive, so we're only looking for the positive root. So this is the square root of a over pi is equal to r. And then lastly, we just make sure r is on the left hand side so we can swap these around, taking advantage of the equivalence principle of equals. So r is equal to the square root of a over pi. Okay, let's have a go at using one of these formulae. Let's say I have enough flowers to cover 12 square meters of ground. So let's say 12 meters squared worth of flowers. And I want to make a circular flower bed in a park where the area covered is 12 meters squared. So what radius of circle am I going to need to trace out? Well, we know that area is equal to pi r squared, and we've already solved for r already, but let's do that again. So a over pi is equal to r squared. So r is equal to the square root of a over pi. And now we just put our numbers in. So r is equal to the square root of 12 over pi. Now, because I'm a gardener in a park, I'm not going to worry so much about the 3.14 and whatever. I'm going to simplify pi to just 3 because I'm only interested in it being about right. So let's say that r is equal to the square root of 12 over 3. So r is equal to the square root of 4. So r is equal to 2 meters. Now that's not going to be exactly correct, but it's close enough for the purpose of a gardener in a park. Okay, so that's all we do when we come to use formulas. We just plug our numbers in and do the calculations. Okay, let's try one more example. Let's take something like force is equal to Newton's gravitational constant multiplied by the mass of one object multiplied by the mass of the other object, all divided by the centre to centre distance between the two. Okay, so that's the famous gravity formula from Newton. Let's try and say that we know the gravitational constant, we know the mass of the two objects. No, let's say we know the mass of the larger object and we know the distance between them and we know the force of gravity, and we're trying to find the mass of the smaller object. So let's solve for little m. Okay, in this case what we're going to need to do is multiply both sides by r squared. So f r squared is equal to g m m. And now if we just divide both sides by gm, we'll get m on its own. So if we divide by gm, the gm's cancel, and we're left with fr squared over gm is equal to m, and then lastly we just swap them round, so m is equal to f r squared over g capital M. Okay, I hope that was helpful. Why don't you have a go at making up some formulae or looking up some formulae and swapping them round to make various variables the subject of the formulae. I'd like to wish you all the best with your revision and all the best with your exams, and I'll see you in another video.